Hi, my name is Teddy, and I'm going to be talking about gate control theory. So, two things you need to know about gate control is there is two parts to it. There's the ascending and the descending. So, an example to describe what's going on in ascending is, let's say you're a baseball player, you're up to bat, and you get hit by the ball. Immediately, once you get hit by the ball, you feel pain, and that pain is your nociceptor stimulus that is going to your brain to be processed as pain. Um, and so what's happening is those are your C and delta fibers or stimulus. Now, when you get hit, it's going to hurt, so you immediately start to rub. And then you notice that the pain reduces, it starts to decrease. So you keep rubbing. And the reason why the pain goes down is because your rubbing sensation is your A beta fibers. Those are your sensory fibers. They're a larger diameter while your C and delta fibers are smaller diameter. And they're both going to the same place to be processed as a stimulus. And then so I drew a little picture for you guys. So here you go. This one is the A beta, or the sensory fibers, and it's more larger and activated. And then here's your C and delta fibers, which are your pain nociceptor fibers. And they're also going in the same place. But what happens is the beta, it stimulates the interneuron or inhibitory and the T cell, while the C fibers and delta just stimulate the T cell. But the reason why you don't feel pain is because this is more activated and larger, and the T cell can only transmit to the higher power 1. And what happens is this beta blocks out the nociceptor. So you don't feel pain because you only feel the sensory, the rubbing. And so this is the old one, but they realized that this was incomplete, and so they made a new one. And this is almost the same thing. All that's going on with this one is there is cognitive control, which is your emotions, and then a descending control, or descending inhibitory control. And it's all being processed into the higher center. And what's going on with that one is you have a lot more that comes in the play of pain. There's more to it than just actually getting hit. There's emotions, there's feelings, which is the same thing, but there's just a lot more that happens with it. And then one of those things is endogenous opiates. What this is there's hormones being released, and one of them comes from the hypothalamus. And the hypothalamus then stimulates the pituitary, and the pituitary makes beta endorphin. And beta endorphin inhibits pain, so you don't feel it, and it decreases it. And this gets transmitted into the blood, so it goes everywhere. You also have enkephalin, and enkephalin goes directly to the interneuron inhibitory, which is the eye in the picture here, in this picture. And that also decreases pain. And then as well, you have central biasing. Central biasing it comes from the cerebral cortex, and that's where your emotions are processed. And then I wanted to be clear that all of this comes from the brain, so the higher center where pain is processed. And then your brain as well is trying to reduce pain. And so with central biasing, getting back on that, it has the Rafe nuclei, and what that is doing, there's actually three things that it can do. It's linked to enkephalin, which we just learned works with the interneuron inhibitory factor. And then there's also serotonin, which activates enkephalin. And then there's also norepinephrine, which inhibits pain as well. And this all acts straight on the spinal cord. So you have a lot of things that are trying to help you decrease your pain, because we know that we don't want pain. Pain is not a fun situation. It's very uncomfortable, and we try to do anything we can to decrease pain. Well, your body is doing that as well. So that is going on with gate control theory, is you have something that's painful, you rub it, and you and your body is doing everything to not have you feel pain. And that is gate control. Thank you.